MS Ramaiah University of Applied Sciences.
Hi students, let us discuss determination of shrinkage limit. The aim of the experiment is to determine the shrinkage limit of the given soil sample as per IS 2720 Part 6 1972. Consistency of soil is its resistance against deformation. It represents the relative easiness with which the soil can be deformed. Consistency limits relate to the degree of firmness and is directly related to strength. Consistency limits are also known as Atterberg limits. As water content decreases, the soil changes from one state to other, liquid to plastic, plastic to semi-solid, and semi-solid to solid. Shrinkage limit is the water content of the soil when the water is just sufficient to fill all the pores of the soil and the soil is just saturated. Experimental setup: evaporating dish, spatula, shrinkage dish, straight edge, glass cup, glass plate with 3 prongs, oven, balance, mercury, distilled water. Experimental procedure: take around 30 grams of soil passing through 425 micron. Mix the soil sample with distilled water such that it can be readily worked into the shrinkage dish. No air bubbles should be trapped. Water content of the sample should be a little over the liquid limit. Coat the inside surface of the dish with Vaseline so that the soil does not stick to the dish. Place the soil sample in the dish by giving gentle taps. Strike off the top surface with the straight edge. Clean the outer surface of the shrinkage dish. Weigh the shrinkage dish containing the wet soil and record it. Keep the sample in an oven for 24 hours and dry it. Weigh the shrinkage dish with dry soil pat. To determine the volume of the shrinkage dish, place the dish in an evaporating dish and fill it with mercury until it overflows slightly. Press it with plain glass plate firmly on its top to remove excess mercury. Volume of the shrinkage dish is obtained by weighing the mercury, which fills the shrinkage dish, and dividing it with the unit weight of mercury. This volume is equivalent to the volume of the wet soil pat. To determine the volume of the dry pat, place a glass cup in a larger one and fill the glass cup with mercury such that it overflows. Remove the excess mercury by covering the cup with glass plate with prongs and pressing it. No air bubbles should be entrapped. Wipe the outer surface of the glass cup to remove the adhering mercury. Place the glass cup filled with mercury in another larger dish which is clean and empty. Place the dry soil pat on the surface of the mercury in the glass cup. Press it using glass plate with prongs and obtain the displaced mercury. Weigh the mercury displaced by the dry soil pat. Volume of the dry soil pat is obtained by dividing the weight of the displaced mercury with the unit weight of mercury. Repeat the test for 3 times for a given soil sample. Data collection and tabulation is shown in the table. Shrinkage limit WSL in percentage, shrinkage ratio R are calculated using the formulae. The results of shrinkage limit WSL and shrinkage ratio SR are presented.
Dear students, in the consistency limits determination, previously we have determined the liquid limit. Now we will determine the shrinkage limit of the given soil sample. The apparatus required for this include the weighing balance. The weighing balance is used to measure the soil sample. This is the glass plate with 3 prongs and is used to wipe out the excess mercury from the dish. Porcelain dish. The porcelain dish is used to measure the mercury. Shrinkage dish, which is used to prepare the soil sample for the shrinkage limit test. a mercury measuring glass dish. The glass dish is used to measure the mercury and used to find the weight of the dry soil pad. This is the mercury which is used for the test to find out the volume. The measuring jar is used to measure the water for mixing the soil sample. Sieve of size 425 microns with a pan and a lid. The pan is used to collect the sieved soil sample. Tray and a trowel are used to collect the soil sample. Now let us start the experiment. So first we will take the soil sample. This soil sample is the same as that which we have used for liquid limit determination. Similar to that experiment, we will sieve this soil sample through 425 micron sieve. Open the lid of the sieve and pour the soil sample into the sieve. Now close the lid and we will sieve it manually. Now measure around 30 grams of the soil sample. So first place the porcelain dish on the weighing machine and tear the weight to 0. Now pour around 30 grams of the soil sample into the porcelain dish. Now mix this soil sample with sufficient amount of water so that a wet paste is formed. Now take the shrinkage dish, weigh its empty weight. So first tear the weighing machine to 0, place it on the weighing machine, observe the empty weight. Now we will fill this shrinkage dish with the soil sample which is prepared. Now fill the shrinkage dish, and while filling, care should be taken that no air bubbles are entrapped. So it is better you tap it in between the layers. Fill it to the top volume. Now weigh the wet weight of the soil sample. To get the wet weight of the soil sample, you have to deduct the empty weight of the shrinkage dish. Once weight is taken, place this in the oven and keep it in the oven for 24 hours. Now this is the hot air oven which is used to find out the moisture content in this. Switch on the oven and we can set the temperature here to our required temperature. For the sample we keep 105 degree. So currently it will show the temperature which is set in this. Now it is 30. If you set it to 105, automatically the temperature rises and it becomes 105. So I am going to keep the sample in it. Now you can see the temperature will slowly rise and reaches to the set value of 105. Now the sample has to be kept in the oven for 24 hours. After 24 hours we will take the sample. After 24 hours, remove the soil sample from the oven. Care should be taken while removing the soil sample from the oven because it will be hot. Now you can see that the sample is completely dried and a soil patch is formed. Now the next step is to determine the volume of the soil patch as well as the shrinkage dish. For this we are going to use mercury. Now place this shrinkage dish on this porcelain dish carefully and then pour the mercury into this shrinkage dish such that it just fills that shrinkage dish. Pour it slowly and carefully. Fill it till the brim of the shrinkage dish. Now we have to weigh this mercury which is filling the shrinkage dish. For that, since we have to carefully handle it, it is better to pour it into the bigger dish and weigh it. Now place the porcelain dish on the weighing balance and weigh. Now the weight of the mercury is obtained by deducting the weight of the porcelain dish. Now if we know the weight of the mercury, dividing the weight by the density of mercury, we will get the volume of this shrinkage dish. That volume will be equal to the initial volume of the wet soil pad. The next step is to determine the volume of this dry pad. For that, we will use this glass dish. Now, place the glass dish in the porcelain dish and fill it with mercury. Mercury should be filled till the top of the glass dish. Now, no mercury should stick to the surfaces. Place the dry pad on the top of this mercury and press it down with the prongs. Now the volume equal to the volume of the dry pad has spilled into the porcelain dish. Now we will weigh the mercury which is collected in the porcelain dish. Now the weight of the mercury will give the weight divided by the density of the mercury is going to give you the volume of the dry pad, and that finishes the experiment.
At MSR UAS, we spark your imagination unlike any other.